In this presentation, we set up a function or procedure to simulate a hospital ward, and it simulates with a standard of in beds with a Poisson process and a Weibull distribution for the occupancy duration and the arrival rate. And we're trying to basically simulate how patients flow through a hospital ward with ranking their stay time and their departure time, as well as running through several different states. The first events are actually bound, and it is an arrival, a normal scheduled departure, and then the conditional events are a normal admission of a patient, admission of patients following early departure, and referring patients. And so we set up each of these scenarios in the code as follows. We are going to walk through together. So we have to initialize all the variables first, and this is given in the first scenario for the appendix problem. And then we go into initializing the cumulative occupancy at each bed, and we display that. And then we get into simulating the actual hospital ward. That's what we're doing. And so our first state that we are simulating is the arrival, and that's basically simulated through the number of arrivals. And if our clock equals that, then somebody is showing up. And then we're going to reset our A variable, which stands for the time of the next arrival, to the clock with that relationship right there, according to the Poisson process, as we know. And if the clock does not equal that, we're taking one away or adding. And then these other state changes are the ones we just talked about through normal admission, or the conditional state change of the admission of a patient following early departure, and the conditional state change of referring a patient. And at the end of all this, we're storing our simulation time and the time of our next departure. And at the end, we are calculating the necessary statistics for this problem. In the end, we are calculating a few important variables, and these are the utilization, which is very close to the given result of the simulation, which is actually 0.705 instead of 0.6954. But since there's a difference in seeds, then that is why there's that difference. The referral proportion is actually known as R, and that one is slightly higher. It is 0.125, and the reason for this is possibly because we cannot get the same amount of simulation time. Their simulation time is much greater, and we simply do not have time for that. And the early departure proportion is correct, as it is 0, and the average reduced stay in early departures is also correct, because that would also be 0. And so with that, our F statistic that we're also looking at is the proportion, or actually shows the time of the stay in the beds versus the simulation time. Thank you for watching.